Hello, my name is Majid Taheri, the graduate student in Sahand University of Technology, Tabriz, Iran. The title of my paper is The Investigation into the Stability Behavior of Single-Layer Braced Domes with Bolt Column Joints. The contents of this presentation are seen here. The stability behavior of single-layer reticulated shells should be considered in the analysis and design procedure. Although rigidity of joint have a significant influence on the stability behavior of single-layer reticulated shells, but in most analyses and design procedure, it is assumed that joints are pinned or rigid, and the actual behavior of joints called semi-rigid is rarely used. Recently, the research on the stability behavior of single-layer reticulated shells have increased. In this table, we gathered the most important of these studies. As seen in the result column, all results indicate that rigidity of joint have huge influence on the stability behavior of single-layer reticulated shells. In this paper, we focused on the stability behavior of single-layer braced domes. Let me, for convenience, say A domes with bolt column joint. Let's say BC joint. By the way, in the first step, let's talk about BC joint. The BC joint, this and this, is designed and investigated by Ma et al. In order to connect edge, I-section, boxes, member, and so on in single-layer reticulated shells. This joint consists of, see here, column node, bolts and washers, con part, and etc. This chart shows moment rotation response of BC joints. Here, it's good to mention that S1A and S3A are used in this study as semi-rigid joint. For the structural configuration, we use elevated separate domes with a span of 40 meters that you see here. The main structural parameters, the rise to span ratio 0.1, 0.25, 0.5, that for convenient and based on this instruction, we call them R04, R10, and R20. The joint bending behavior, pin joints, rigid joints, and 2BC joints, S1A and S3A as mentioned before. 5 member sections, pipe, I-section, and 3 boxes, and finally 2 load cases, uniform loading in all nodes or concentrated load in central node. ABAQUS software and RIGS method are employed for this study. The members are elastic perfectly plastic being young modulus of 205 gigapascal and yield strength 235 megapascal. Von Mises yield criterion and B31 elements from ABAQUS library that is based on Timoshenko theory. The joints are modeled with 3 nonlinear spring elements, see here, with 0 lengths in each side of members. We use CON32 from the ABAQUS library for this aim. The most single-layer cylindrical reticulated shell with ball joints are used for validation of FE model. The configuration of test model and the moment rotation curve of ball joints are seen here. The below chart shows that it is negligible difference between the result of FE model and the test data. The numerical results. First, effect of rise to span ratio. The charts show that in each loading conditions, rise to span ratio has a great influence on the stability behavior of single-layer reticulated shell. As another point of view, we can see in these charts and these charts that shallow domes with pin joints have no bearing capacity. In this slide, we can say according to difference between curves in these peaks, we can conclude that the effect of member section is low. Only in first chart we can say some difference. Effect of joint rigidity on ultimate buckling capacity of domes are shown here. First, the joint rigidity increases the capacity of domes. Second, the capacity of domes with pin joint, as mentioned before, is very low. Clearly, in here, 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 and here, we can see that the domes has no bearing capacity. Finally, we can say in this part and according to this chart, the amount of joint influence depends on other structural conditions like loading condition and etc. In this chart, differences are grid, and in this chart, differences are load. Results. The BC joint exhibits a good performance in the single layer braced domes as a semi-rigid joints. The ultimate buckling capacity of domes are increased with the increase of rise to span ratio. The rigidity of joint has a huge influence on the stability behavior of single layer braced domes. The effect of joint rigidity on the stability behavior of single layer braced dome depends on the joint property, the configuration of braced dome, load pattern, the beam cross section, and etc. The bearing capacity of single layer braced domes with pin jointing system is very low. The effect of cross section on the stability behavior of single layer braced dome depends on the rigidity of joints and the loading parameters. The references that used in these slides, and thanks for watching.